So imagine a factory where you need to flash hundreds of boards every day. Now imagine there's a situation where there's a fault and the entire launch stops. So we try to solve this problem. Good morning, everyone. Our session today is based on flashing tools and with primary focus on Snag Factory. My name is Paresh Bhagat. I'm from Texas Instrument, and I'm here with Romain from Bootlin. So Snag Factory is a collaboration between TI and Bootlin. Snag Factory is an open source project which also aligns with TI and I'm pretty sure Bootlin's upstream first approach. Like you'll see us contributing to many open source projects like Linux, bootloaders, distros like Yocto, Buildroot, etc. So let's quickly go through the contents. I'll be explaining mostly about problem statement and a little bit about the TI's own flashing tool. And then Romain will explain you all about Snag Factory. We do hope to get some feedbacks on Snag Factory and maybe more contributions to this project. So we generally have two approaches to flash our devices. One is before soldering and second one is after soldering. The before approach uses a specialized hardware. It's faster, but it's not very flexible. The second approach is flexible, but it's not very fast. It depends on the interface, like USB or UART. So in this session, we'll be mostly discussing about the second approach, not the first one. So these are some of the problems we found in the flashing tools available today. First is time consuming. If your flashing tool is slow, it can slow down your production line. GUI-centric, it's not very difficult. It's easy, but it's not so difficult in automation scenario. No scalability. Suppose there are some tools which does not support multiple devices, or there's a limit to some devices you can flash. Closed source tools, they are very difficult to customize and integrate in your flow. Poor cross-platform support. So some tools support Windows, some Linux. Like we have many customers who wanted Linux and maybe some wanted Windows support. And many tools are actually vendor specific, so it's not compatible to your devices. So to solve this problem, we TI developed our own tool known as U-Boot Flash Writer. It's a Python-based tool. It's a kind of wrapper to DFU util. It supports both Linux and Windows. You can go through this link and maybe try it out yourself. It's pretty easy. So I'll quickly discuss the flow of this tool. So in step one, you have all your devices connected to your host PC. And these boards will be in recovery mode, or we can call it DFU mode. In step two, the tool will actually detect all the devices which are connected to the host PC, and it will recover those boards by sending out the modified bootloader binaries. Actually, Neha is also presenting, so on the third day. So, in step three, the boards are actually ready. Boards are booted till U-boot, and the host PT will send out a UNVA file, which will be passed by U-boot, and it will make the board ready for flashing to our onboard memory, like eMMC, NOR, NAND, ChipMC. Step 4, everything is set, and tool will begin flashing your actual binaries to the board, to any onboard memory. So what are the features of our tool? It supports factory flashing. You can actually connect multiple devices, and it will flash them parallelly. Error reporting, it will tell you what are the devices has failed to flash, and you can modify it and reflash them automatically. Supports both Linux and Windows, Python, and it supports multiple boot media. You can, as long as you have support for U-boot and DFU util, you can flash to multiple boot medias. But like every other tool, we do have some limitations. It needs U-boot support. You need to have U-boot, DFU util support in your devices to make it work. No GUI, yeah, it might be difficult for some people. And speed, actually DFU util does not use bulk transfers, so it's kind of a hey there. So I think Romain will explain more about how the Snag Factory solves this problem. So over to you, Romain.
Okay, so Snag Factory as a tool really didn't come from nowhere. It's actually an extension of a pre-existing tool called Snag Boot. And so Snag Factory as a tool doesn't really make sense without the context of its mother project, let's say. So let me maybe talk a bit about Snag Boot beforehand. This is a Bootlin project which was released publicly in 2003. It's a recovery and reflashing tool. So just like every other reflashing tool, its goal is to take a device and reprogram it with any kind of software over a USB link. And usually how this is done is by leveraging some kind of ROM code USB recovery mode, which is very SoC vendor specific. And this is part of the reason why all of these tools are usually very SoC vendor specific. So they have different CLIs, different requirements. And so this kind of creates some awkwardness for people who have to work with a lot of different boards. And it's also not ideal for factory flashing because you need to get factory operators used to all of these different tools and all of their differences. So having something unified and vendor agnostic was quite desirable, and this is where the idea for Snag Boot came from. So one of the key principles in the architecture of Snag Boot is the separation between recovery and flashing. What we call recovery in this context is basically just getting a bootloader, in our case U-boot, running on the target in external RAM and without touching any of the non-volatile memories of the device. So this is really the, let's say, the scope of the recovery task. And after this comes the flashing task, where we talk with this feature-rich bootloader to actually get something written to these non-volatile memories. This is why Snag Boot is divided into two different CLI tools. You have Snag Recover, which is SoC specific, so you have to pass it a SOC model. And then it will download and run U-boot on the target without touching any of the non-volatile memories. We picked U-boot because of its very wide support range in the ARM universe. And what's really great about this separation is that once you have the device recovered, the rest of the process is essentially SoC agnostic, because once you have U-boot running on the device, well, you're basically just talking to a standardized USB gadget exposed by U-boot and no longer to some kind of SoC vendor-specific ROM code device. So this is why the actual code base for Snag Flash is much, much simpler and smaller than the one for Snag Recover, because it only has to know about the standard USB flashing gadget protocols. We support fastboot DFU or UMS. And this is the part that will actually write to non-volatile storage. Here's just a quick recap for the people who are more visual learners, let's say. So with Snag Recover, we just send U-boot to external RAM. Once U-boot runs, we use Snag Flash to write something, say, for example, to an eMMC. So in this case, it's a Linux system image. And then we can, well, just whatever, perhaps reset the board, perform some tests, get it to boot from the eMMC. This is the current support range for Snag Boot and specifically for Snag Recover. Right now, we actually have 7 released supports. Broadcom support is merged in master, but it's not released yet. It will be in 2.5. And so we can see that over the years with Bootlin's work and also with external contributions, we've actually managed to gather quite a wide support range, which is very nice and desirable, because this is one of the goals of the tool, to get something that has one single user interface for various kinds of SoCs. So this is the kind of configuration that you'll pass to Snag Recover. Snag Recover for each SoC model has what we call a recovery flow, which is basically just a list of bootloader images that you want to send and run on your target. The last one of these firmwares will be U-boot proper, what we actually want to run on the target at the end of the recovery. And before you boot, you usually need at least one first stage bootloader to initialize external RAM, sometimes more. In this case, AM62X, we have 3 different firmware images that we need to run, like TI boot 3, TI SPL, and then U-boot proper. And we just have this firmware config file where we tell Snag Recover where to find precompiled images for these bootloader stages. For Snag Flash, things are pretty different, because once again, it's just dealing with standard USB gadgets. And so you just specify the protocol you want to use. So this will be dependent on the kind of gadget you decided to expose from your U-boot proper. And this is either DFU, UMS, fastboot, or fourth protocol, which I'll mention quickly later on. DFU, you basically just send files to alt setting numbers, which correspond to either regions of storage or regions of memory. UMS, you're just writing to a block device, and fastboot is a protocol by Google, which has a list of predefined commands which can be used to send images, write them to storage, or other useful commands. We have this fourth fastboot U-boot protocol. This is actually a base of standard fastboot with some added functionality on top. This basically leverages some extra features that U-boot fastboot support has, and this is important because it's actually used by Snag Factory in the backend to make the factory flashing process a bit more efficient. This is all for the basic presentation of Snagboot, so now I'll actually explain how we extended the tool into something capable of doing factory flashing at a large scale. If we look at what we had before Snag Factory, we had two Linux CLI tools, a recovery tool and a flashing tool. And what we needed to actually meet the requirements of the project TI wanted to realize was Windows support, because the people on factory floors usually use Windows. A GUI, because again, the people who will be using this software aren't necessarily software people and don't necessarily want to work with CLI tools. So a GUI is desirable in this case. Also, it allows for a more practical viewing of a lot of different boards doing different things at the same time. And last but not least, parallelization of tasks. This is extremely important for the speed aspect, right? Because if you have 12 different devices connected to your computer, then you want to utilize the parallelization capacities of your CPUs and USB topology as much as you can to actually get this batch of boards prepared as quickly as possible. Here are the main development milestones of the Snagboot project. So V 1.0 was released in May 23, 2023. We had 6 SoC families, DFU, U-boot, fastboot, UMS fastboot, sorry. 1.3 was released in towards the start of 2024, and this is actually where development on the Snagboot project kind of stalled, because towards this time we actually started working on Snag Factory, so we didn't really have time to do any meaningful work on Snagboot during this time. But once Snag Factory was prepared, towards November 2024, we released it and bumped the major version number and integrated it into Snagboot. So this is V2.0 is the first version with this new factory flashing tool, Windows support and everything. And since then, we've actually gotten quite a spike of new contributions to the project. So thanks to this, we've been able to add various SoC supports. For example, Intel Kimbay support was contributed by someone external to Bootlin. ZyncMP and MP2 were contributed by us, and we have actually a Rockchip support in the pipeline right now, as well as Broadcom support, which was just merged this morning, actually. Yes. Here's the user interface for Snag Factory, so please keep in mind I am not a UI designer. I am a kernel developer, so I did my best. So here we have an action bar on the left and then a board status list on the right. The board status list is what allows you to view all of the devices which are currently being processed by the tool, along with their, well, what the tool is currently doing to them, their status if they failed or something. On the left, you have, well, this big button at the top, which is used to start the factory flashing session. The gear icon here can be used to switch to the configuration view so that you can check what you're actually planning to do to these boards. And the USB icon is just to switch back to the board status list. This conf icon here can be used to load a configuration file into Snag Factory, and this is how you will describe where your recovery files are and what kind of tasks you want to run on these boards. And the magnifying glass icon thing is for viewing log files. Basically, every time a factory flashing session is run, you'll automatically have all of the logs of the session saved into the app data of Snagboot, and then you can pull them up later in the UI using this button. There are 3 phases in Snagboot factory flashing run. First, there's the scanning phase. This happens as soon as you load the configuration file into the UI. And at this stage, Snag Factory will begin to enumerate regularly all of the devices connected to your computer. And it will register those that match your configuration file and show them up on the UI here. So right now, nothing is being done to these boards, but once all of them are present, you can click Start and get the factory flashing stage going. So here you'll have separate progress bars for each different board along with their current state. So you can see here we have some flashing boards. One board has a failed recovery task. And if you click the show log buttons here, you can get individual detailed logs for each board along with what's happening. It would be nice to also add a pane to have like the general logs of Snag Factory. This will probably be done later when we find the time. And after the factory flashing session is done, so this is when all of the boards are either in the done state or the failed state. And at this point, the session will be saved to a log file, and you'll be able to view all of the logs using the same UI, basically. This is also the kind of view you'll get if you load a previous log file from a previous run. Now for a little tutorial on how to actually fetch, install, and use Snag Factory. On Linux, the dependencies are pretty simple. It's Python at least 3.9, pip, ensure pip if you want to install it in venv, and of course libusb, which is kind of the main dependency of the tool because it's used all of the time to communicate with the devices. We have a PyPy package. Just pay attention to something. It's that we have a GUI variant, which is the one which actually provides Snag Factory. The reason for this is that when we added Snag Factory, we pulled in a dependency for the GUI library called Kivy. And a lot of old users of Snag Factory did not want to deal with this dependency, so we kept it out of the base package and we added a GUI variant. So if you want to have Snag Factory, you need to install the GUI variant of Snagboot. You can also install it from source. This also indirectly uses pip, but it uses the local sources. And there's an install script for this. Just once again, make sure to pass the with GUI argument so that you actually get Snag Factory. On Windows, things are actually pretty similar. We just have this additional dependency here, zadig. This is not actually a full runtime dependency of Snagboot, but you'll see later that we rely on it to handle and to manage a USB driver binding to devices. There's the same PyPy package. The installation process is very similar. You can run this in PowerShell. From source, we do not have a script like in Linux, but you can actually just run pip install.gui and it will work. And then we also have in each release, we package a binary installer with a setup wizard for Snagboot. One, I'd say, stumbling block for a lot of people when they first start using Snagboot is USB access rights. On Linux, Snagboot requires read-write permissions on USB devices to actually send libusb transfers to them. And the solution for this is usually to have some UDEV rules which match on vendor IDs and product IDs and add a uAccess tag so that you can get the proper access rights to the device. Something to note is that we cannot handle every possible VID-PID pair out there. For ROM code gadgets, we do have some provided VID-PID lists. So if you run snag recover UDEV, you'll get a big UDEV rule file with all of the basic ROM codes that are available. However, U-boot gadgets have fully customizable VID-PIDs, so we cannot just put a file with every single VID-PID and give access. That would be a security nightmare. Or do something like add access to the VID-PID 0000000. That's not something we want to do. So yeah, basically the takeaway here is that if you have a custom VID-PID, you should add your own UDEV rule for it. On Windows, things are simultaneously a bit more complicated and quite different. So on Linux, if you don't have Okay, I'll try to not go too slowly then. If you do not have high-level driver bound to your device, you can still talk to it using libUSB transfers. Like if you don't have an HID or CDC or anything kind of driver bound to it, you can still send transfers to the bus device. On Windows, this isn't the case. You have to bind a driver specifically to the device, which is libUSB compatible. And this is what we use Zadig for. So this is a pretty simple to use tool. You just plug your device in. If it's unrecognized, it'll show up in Zadig, and then you can tell it to bind the libUSB 0 driver to it. And then once you do this for a VID PID, normally you don't need to do it again, apart for when Windows Update decides to mess up your entire setup, but that's besides the point. And then you'll be able to use Snag Factory with it. Just some documentation shortcuts. So the README should take you to every single place in the docs, but if you want some shortcuts, you have hyperlinks here in the slides to the Snag Factory specific doc and the configuration file reference format. Here's the Snag Factory configuration file. So just like the Snag Recover one, it's a YAML file. You have a boards section here, and this will be used for the scanning phase. So a Snag Factory will be harvesting all of the devices which match this VID PID. And you also have this SOC model value, and this will be used to match the next section. So each SOC model will have a firmware section and a tasks section. The firmware section is basically exactly a Snag Recover configuration file. So it's what we saw earlier. You just pass it the paths to your precompiled U-boot and other bootloader stage binaries. And once you have that, this will allow Snag Factory to actually recover the board. The task section, which will have what we call a task pipeline. This is an ordered list of tasks. So these are predefined and provided by Snag Factory. And each of these tasks will be run in order. And if one of the tasks fails, then the pipeline stops and nothing is run after it. We also have at the beginning these special items which are global variables. We need these to set things like the target device for the flash command. And so yeah, we can have different task pipelines for different SOC models, even if that's not extremely common. Just an illustration of how the task pipelines are actually run in parallel. So here we have some pending tasks in white and some running tasks in brown. Each board has, in this case, the same pipeline of tasks, although they can be different if you want. And they are all run in order. So please note that it seems here like all the tasks are run one after the other, but they're really run in parallel. So we have a main loop in Snag Factory, which let's say constantly checks all of the device statuses in the board list, and every time it sees that a task has finished, then it's going to start a new one by forking it to a new process and then immediately move on to the next board. Here we can see some completed tasks in green and also a failed task in red. So once the task is failed, then none of the subsequent tasks for this board are going to be run. However, all of the other boards are going to continue their business as usual. Here we have one typical example of a final state for the boards. Here we have 4 successful task pipelines and 1 failed one. So this would correspond to what you'd see in the log view phase at the end in Snag Factory. Now I'm going to just list off some predefined tasks which you can use in your pipelines. The 3 most important ones are flash, GPT, and run, I'd say. The flash task here is used to just write a file either to partition in hardware or to an entire hardware device. The different targets are quite varied. You can just pass it, well, just not pass it a port argument and it will flash it to your entire target device at offset 0. You can also pass it the name of a GPT partition, the name of a logical MTD partition, or you can also tell it to flash to an eMMC boot hardware partition. Images, there's the path to your image file, and the image offset is optional, but it can be quite useful. For example, when you're flashing to hardware partitions, you have this kind of standard setup where you want to flash multiple images at different offsets inside of the partition, so this can help you do that. This actually has quite a lot of complex logic besides it. It can detect if there are BMAP files and use them to flash in a sparse way. and it also supports what we call larger than RAM files. So Snag Factory uses fastboot in the backend, and the standard way of writing files in fastboot is you send it to a buffer in uboot RAM, and then you send a separate command to write the contents of the buffer to your device. And so this is problematic if you have like a, let's say, 10 gigabyte system image or something. It will not fit in RAM, no matter how hard you try. So Flash will actually take care of detecting this, and it will cut up your image for you and flash it in offsets so that you don't have to deal with that. It has one global variable requirement. It needs a uboot fastboot buffer address. Next, the GPT task is just a description of a partition table that will be written to an MMC device. So this is only for MMC. So you have all of these standard GPT partition attributes like name, type, UID. Pretty standard. The run command is used to run a snag flash command. This makes, let's say, the task pipeline a bit more flexible and allows for some more freedom. I'd say the main use case for this is running OEM run. What this does is it allows you to run an arbitrary uboot shell command. And this is really what you'd use if you want to perform some kind of factory flashing task and you don't have a task for it provided in Snag Factory. For example, let's say I want to write some OTP fuses, run some CRC checks on memory or something, then I can just write a uboot shell command and send it with OEM run. These are the other tasks available. They're a bit less used, so I've included them, I've kind of lumped them together. MTD ports. So this doesn't write any kind of partition table to the raw flash device because that's not usually how you do MTD partitions. Instead, it just writes the list of partitions to uboot environment to the MTD ports variable. And what's interesting actually with this is once you've defined MTD partitions with this command, then if you have a flash task later in the pipeline, you can pass the name of one of your MTD partitions to actually flash to it directly. Prompt operator. This is useful if you want to, at some point in your task pipeline, stop doing things on the board and ask the operator to do something like a hardware manipulation, some kind of check. So when Snag Factory encounters this task, it will pause the pipeline, display the message you provided in the UI for this specific board, and then the operator will perform the task that you ask him to, that you ask them to, and click the play button so that the board can resume once he's confident that everything is okay. The reset task here just sends a uboot reset command to the device, and then it will rerun the recovery process so that you get another uboot shell again. One use case for this is like if you're doing MMC hardware partitioning, and with some eMMC devices, you have to reset the hardware before you get the new hardware partitioning setup available from the software. So in this case, you can do your hardware partitioning and then reset and then do your business as usual. And the final task we have is eMMC hardware part. So you might be aware that for eMMC devices, you can have different hardware partitions. So we have these two typical boot partitions, but you can also change sometimes the size of your main area, have some general purpose partitions defined, and also change some hardware properties, like if your certain areas of your eMMC use single layer or multiple layer flash cells. And so this task allows you to set that up. So it's going to run 3 uboot commands, like the verify setup command, and then it's going to write it and then commit it. And at this point, it will be burned into the MMC and you can't change it anymore. So these are all of the tasks which are provided in Snag Factory right now. We'd like, of course, to add some more tasks in the future. For example, something to flash OTP fuses would be nice, but yeah, that will be for later. Now, as I said, at the end of each Snag Factory session, you'll get a log file automatically saved. And this is the basic format of this log file. First, you have the session timestamp and a quick summary of the final status of every board that was handled. So here we have 5 successfully factory flashed boards and 1 which had some failures. The config file that you loaded in will be replicated here. And then you'll have, again, a quick summary of each board, which USB hardware path it was at. Because, yeah, I didn't point this out, but Snag Factory tracks devices. So you give it a VID PID, but once it's found the board with this VID PID, it's going to track it using the actual physical USB port because, well, we can't use the device address because it's going to re-enumerate multiple times. And so this is not reliable. This is why we use the bus port numbers format here. And so this actually identifies a physical USB port on your machine or on a hub attached to your machine. Then there's the general factory log. So this is a high-level overview of the timeline for each board. So you can see all of the main state transitions for each board object. So here you have one which started a recovery task and which went from the ROM state to the recovery state, etc. And then for each board, you have an individual detailed log. And this will actually aggregate all of the logs emitted by Snag Recover and Snag Flash during the process. So you'll get really detailed logs about like what was done to the device at the USB request level. And yeah, so you can load these log files into the Snag Factory UI, and then you'll get these board logs inside of the individual UI panes as we've saw before. So for our development goals, obviously, we're always looking to expand the support base of Snag Boot, even if we have quite a lot of different SoCs supported now. There are permanently new SoCs coming out that we want to support, and also we have some ones which we don't quite support yet. In 2.5, we'll have Rockchick support and also Raspberry Pi. So it's really BCM 27, 11, and 12, if I remember correctly. So Broadcom SoCs, but I think they're only used in Raspberry Pi compute modules. We'd like to improve the UI and also the logging and error reporting, especially in Snag Recover and Snag Flash. We have some especially relating to USB permissions. We have some unintuitive logs being emitted, so we'd like to fix that. Maybe get a nicely formatted documentations like all of the big mature projects have. Right now we just have the GitHub integrated docs. And yeah, introducing new factory flashing tasks would be really nice. Like yeah, for OTP fusing, maybe memory checks, a lot of different ideas come up. And lastly, and this is part of the reason we did this talk, is to get some feedback, because the thing with factory flashing, it's a kind of activity which everyone kind of does like on their own side. There isn't really a lot of open discussions about the typical workflows and tools that people use for this. So it would be nice to get some feedback from people who actually like have these problems and use cases, so that we can make something that would be a nice open standard that can be used for this purpose. So that's all for me. Thanks for listening, and we'll be taking your questions now. So we don't have pre-made support for that. However, this is something that you could do already with U-boot shell commands. It would be nice to have commands for that. The thing is, it would be really hardware specific. There is the U-boot LED command and yeah, maybe the CRC command if you want to do memory checks. And that is something we could do as a separate factory flashing task, but right now you'd have to do it with the OEM run task, like by sending U-boot shell commands. Yes, over here.
What do you offer in kind of bookkeeping and export for a production database?
I guess you mean like the a kind of database of the factory flashing tasks you're running, the kind of boards you're, yeah. Okay. So yeah, this is really not something we've put in the scope of our project right now. This is really an operational tool. So you have something that you want to do, and your this tool really intervenes towards the end of your assembly line. So no, this isn't right now, at least in the scope of the product. Like, it's not meant to organize your entire like production process. It's more tailored to this specific part of your production process, I guess. Yes?
The physical connection medium that you have right now is USB. Do you also have plans to have a LAN for your network?
So as far as Snag Factory is concerned, it's very USB oriented. We've had some discussions about adding support for things like JTAG and maybe UART. We do at the Snag Recover level, we actually do have some support for one UART recovery, and we're thinking about adding support for JTAG for a specific board, but this is only at the recovery level. The thing is, if we want to support actual flashing tasks over these mediums, we need to have U-boot support exposing gadgets over these interfaces. So yeah, I guess that would kind of change a lot about how the tool works internally and how the logic is set up, but it's not something that we would completely exclude. But right now, I wouldn't say this is the case now.
Yeah, I am concerned with performance. I have struggled in the past with DFU builds too slow to download the files. Is this tool not good faster? Or is it dependent on the protocol?
So I'd say yes to both. So the added cost of a Snag Factory over something like DFU util, I'd say would be mainly seen in the flashing stage and also when you're scaling up with multiple boards. The thing is, DFU has a fundamental problem, is that it does everything with control transfers. And so if you want to send like a sizable, let's say, bootloader image for recovery, then you have to cut it up into control transfers, which is slow. Whereas something like Fastboot, for example, would send it with a bulk transfer. So we are limited by these protocol constraints. However, in the flashing stages, you will see some improvements over using things like single shell scripts with DFU util, because, well, you have this parallelization aspect which you won't get out of the box with something like DFU util. So authentication to access what kind of resource?
To more or less like, so when it's like completely fresh device, of course there is no fuses burned or whatever, but if you have like fuses burned already like for refurbishing and you still want to have that interface so you can refurbish your devices, but you don't want that everybody can do it.
So I guess you're talking about something like Secure Boot, because you could, so if you're talking about setting up the actual access right management in Secure Boot, then you could do this with a combination of flashing tasks and U-boot shell commands, like by writing the proper fuses, etc. And then, so you could still run a U-boot in RAM, but it would have to be properly signed first when you compile it with your public key. And then Snag Recover should be able to send it properly to the device. So we've tested this with IMX HAB v4 signed images, for example. If you have a properly signed image recovery will work. And it won't if you have an unsigned image, because the ROM code will just refuse to boot it. And so, yeah, I guess you could do factory flashing on these kind of boards. Yeah, sorry, maybe follow up on.
Yeah, so that's maybe like one part of the solution. I'm a little bit concerned about adversaries at the factory. So if you have like that generic signed recovery U-boot, and then you can do everything with it. If that leaks,
yeah, maybe, but I guess if you have physical access to the device at the factory, there's a lot more. There are a lot more holes in your security than just having like a signed U-boot image with a gadget. But yeah, that's not something we really pondered a lot, because it's not really in our threat model to have like someone at the factory which is trying to maliciously inject images into the board.
On the topic of Secure Boot, do you have any? How would you go about using a flow where you use the functionality to program some OTP fuses and then say close the device and then flash some recovery? Like, is it possible to maybe also a question for Bhagat, because I know TI boards, it's either or. You can't.
So yeah, for the TI specific part, I'll let Paresh tell you about that. As far as Snag Factory is concerned, you could do that by just having like your secure boot commit tasks in the beginning of your pipeline, then add a reset, and it'll redo the recovery, and then you can do your other flashing tasks after this. So this is completely possible. The only technical roadblock you have for this is that right now, if you do a reset task, it will reuse the same firmware images that you had for the first one, so they would have to be signed even in the first stage, which might or might not be a problem depending on the SOC module, I guess. But Paresh, maybe if you can expand for TI.
At least the HSFS and HSSC will expect you all the signed images. So I think that's not possible, at least for this stage. But yeah, we can look into that. Yeah.
Yes.
Is the UI tool or the log messages set up for localization?
As far as timestamps are concerned, the main session timestamp is set to UTC. For the other ones, I actually don't recall right now. I'd have to check.
I'm thinking more languages.
Oh, languages, you mean? No, actually, we only have English right now, but that's a good point. Translations would be nice. Yes.
So the things that load before you that are vendor specific, are those binary blobs or something?
So this is highly dependent on the recovery flow and the SOC model. Usually, there's some kind of compiled bootloader or closed source firmware for some devices. So these you have to pre-compile yourself beforehand or download them from your board vendor if they have some that work. And yeah, so for example, in TI, I think there are like X509 certificates with like some firmwares and a U-boot SPL and other stuff in them. Yeah, that really varies depending on the model. Yes.
So if I have, did I get that right, that you have regular batches of flashing processes and all of them complete and then you start a new one? Or do I just connect a new board as soon as one is finished?
So yeah, good point. Right now, we basically have one configuration which corresponds to one flashing session. So you cannot actually hot plug boards into the factory flashing session. You have to plug all of them, run it, and then plug new ones and rerun another batch. However, we have discussed and we have planned to implement something where you can actually make the factory flashing session a bit more flexible and add boards as they come in. This will require some architectural changes and quite a lot of work, but it's something that we would like to do, yes. Yes.
So what does it take to add a new support for a new SOC? So like, it seems like the goal is to get to U-boot and do as much work there, do it simpler. But if your boot was like a UR boot, how do you like to deal with that?
So, very good question. We actually have an entire documentation page in the Snag boot sources related to this in the developers section, which guides you through the whole process of adding a new SOC recovery flow. It's a bit more tricky if you have a not USB-based recovery. We do have an SOC like AM335X. We have UART recovery for this, but this can really only work for recovery. But as far as the recovery goes, it's pretty similar to a USB flow. You just send your images through this different medium, and at the end, you should get U-boot running. But U-boot will have to expose over USB at the end. Yeah, that's the big limitation right now. I think there was a question over here.
My question just got answered.
Oh, yeah, nice. Yeah. So we've tested eMMCs, SD cards, spine ends, and O-spine NORs. We haven't tested SSDs yet, because they're not that common, I guess, in the devices we typically see. But yeah, that's an interesting question. If you somehow get to test that, that would be, we'd like to have some feedback on that.